everyone, this is Sudheer Kumar working as an assistant professor of mathematics in MLR Institute of Technology. Today in this lecture we are going to cover system of non-homogeneous equations and system of homogeneous equations. In last class we have seen how to solve what is consistency and how to solve the system of non-homogeneous equations. Let us solve more example on system of non-homogeneous equations and solve them. Right. So show that the equations 2x plus y plus z equal to 5, x plus y plus z equal to 4 and x minus y plus 2z equal to 1 are consistent and solve them. Consistent means it has some solution. So we have to find that solution which is x, y, z values. So before finding the solution, first step is these system of equations let us write down in the form of A into x is equal to b, where A is the coefficient matrix which is given by 2, 1, 1, 1, 1, 1, 1 minus 1, 2. Write all the coefficients of these equations. Next, capital X means x, y, z. B means right side values which are 5, 4, 1 is a column vector. Now let us reduce this matrix into echelon form. For that, first of all, I am interchanging R1 and R2. So second row is swapped with first row. So I will get 1, 1, 1, 4, 2, 1, 1, 5, 1 minus 1, 2, 1. Next, operations are, now I have to make this element 0 and this element 0 to reduce into echelon form. To make this element 0, the operation is R2 tends to R2 minus 2R1. And to make this element 0, the operation is R3 tends to R3 minus R1. So we got this matrix. Now coming to, we have to make this element 0 to make it into echelon form. For that I am using this operations R3 tends to R3 minus 2R2. So while making this element 0, these two zeros should not get disturbed. Right. So R3 minus 2, R2, 0, 0, 3, 3. This is the matrix we got on performing this operation R3. Now there is a partition, only this matrix is A and total matrix is augmented matrix A by B. So to check the rank of the matrix, which is given by number of non-zero rows. So there are 3 non-zero rows in the matrix A. So rank of A equal to 3. Total matrix, if we consider, rank of the augmented matrix is also 3. Both are equal. We say that the system is consistent and rank is equal to 3, which is equal to n, number of unknowns. So the system of equations will have unique solution. The system of equations will have unique solution if r equal to n. So how to find that solution means, again write down this equation matrix into equations form. So x plus y plus z equal to right side value 4, let it be equation 1. Second row there is no x coefficient, so write down minus y minus z equal to minus 3. So if you cancel minus, you will get y plus z equal to 3, let it be equation 2. Third row 3z equal to 3, let it be equation 3. So from this equation I can get z value as 1. So substitute z value in the second equation. So we get y value which is equal to 2. Substitute y value, z value in equation 1, back substitution. So we get x value 1. So x equal to 1, y equal to 2, z equal to 1. This is a solution for the system of equations. Now how to verify whether this solution is correct or not? You can cross verify, substitute these values in the given system of equations. 1, 2, 1. Let us check here. 2x plus y plus z equal to 5. So 2 into 1 plus 2 plus 1. 4 plus 1, 5. This is equal. So these solutions x, y, z values are satisfying the system of equations. So this solution is correct one. Now let us see one more problem. find the value of k if the equations x plus 2y minus 3z equal to minus 2, 3x minus y minus 2z equal to 1, 2x plus 3y minus 5z equal to k are consistent. Already given in the question that the system of equations are consistent. If so, we have to find the value of k. So for that, the system of equations can be written in this form: Ax equal to b, where A matrix is given by this, capital X is given by this x, y, z, and capital B equal to right side values minus 2, 1 and k, right. So consider the augmented matrix A, B. We reduce this matrix, augmented matrix, into echelon form. So for this, I have to make this element 0 and this element 0. To make these two elements 0, what should be the operations? R2 tends to R2 minus 3R1 and R3 tends to R3 minus 2R1. So if you want to do the calculations, R2 minus 3R1, R2 means 3 minus 3 times of R1, 3 minus 3 is 0. Next coming to minus 1 minus 3 times of 2. So minus 1 minus 6 is minus 7. Next coming to minus 2 minus 3 times of minus 3. So minus 2 plus 9 is 7. Next 1 minus 3 times of minus 2, which is 1 plus 6, 7. So like that we can find the second row elements. Similarly to third row elements, operation is R3 minus 2R1. So 0 minus 2 minus 2, 0. Next third row element calculations, you can see 3 minus 2 times of 2, 3 minus 4 is minus 1. Next minus 5 minus 2 times of minus 3, this is minus 5 plus 6, which is equal to 1. Next 4 plus k. Next step, we have to make this element 0 by using second row R2. Let us see the operation. R3 tends to, using R2, 7R3 minus R2. So we get all the third row element 0 and this one. Since given that the system of equations are consistent, consistent means both the rank of A and rank of augmented matrix must be equal. Then only we say that the system of equations is consistent, right? Now here all the third row elements are 0. That means rank of A equal to number of non-zero rows, that is 2. Since it is consistent, this element should be equal to 0. Then only both the ranks must be equal, right? So 21 plus 7k equal to 0. So 7k equal to minus 21. So k equal to minus 3. So the value of k is minus 3. Then only the system of equations are consistent. Now let us see homogeneous system of equations. Consider the n equations, homogeneous equations. A11x1 plus A12x2 and so on, A1n xn equal to 0. Right side all the elements must be 0, right? Similarly, second equation A21x1 plus A22x2 and so on, A2n xn equal to 0. So consider the n system of equations where the coefficients a, I, j, these are the I runs from 1 to m, j runs from 1 to n. These are the constants. This solution of equation 1 is trivial solution. For homogeneous system of equations, we don't have any there is any solution exists means either it is a trivial solution, means zero solution, or infinite solutions. Like we have discussed in non-homogeneous, there won't be any third case where solution does not exist. Here compulsory solution exists. Either that solution is zero solution, which is called trivial solution, or infinite number of solutions. These are the only two cases arrive. If rank of A equal to rank of augmented matrix equal to n, then unique solution exists. What is that unique solution? Is zero solution, which is also called trivial solution. This is possible only if determinant of A not equal to 0, right? Case 2. both the ranks are equal but R is less than N, then we say that the system of equations is non-trivial solution. In that case, non-trivial solutions exists if the determinant of the coefficient matrix is 0. If the determinant is 0, then we have infinite number of solution, which is also called as non-trivial solution. If determinant not equal to 0, we have trivial solution called, this is also called as zero solution, where all the variables in the equations x equal to 0, y equal to 0, z equal to 0. Only these are the two cases. Let us see with an example. Solve the system of equations x plus 3y minus 2z equal to 0, 2x minus y plus 4z equal to 0, and last equation x minus 11y plus 14z equal to 0. So consider the augmented matrix which is given by AB equal to this. Reduce the matrix into echelon form. We have to make this element 0 and this element 0 by using these operations R2 minus 2R1 and R3 tends to R3 minus R1. So we get this matrix, right? Next, I want to make this element 0. What should be the operation? On R3 using R2. Using the second row R2, we have to make this element 0. So for that, R3 tends to R3 plus 2 times of R1, R2. So we get these equations, this matrix. At last, I have to get this element 0. So we got this element 0. Now, all the third row elements are 0. So rank of A is equal to 2. Whereas this element is also 0. So we say that rank of AB is also 2. So both the ranks are equal. So 2 less than number of unknowns. So we have non-trivial solution, infinite number of solutions. Rank of A slash O equal to 2 less than 3. 3 means number of unknowns. So we say that the system of equations have non-trivial solution, infinite number of solutions. To find that infinite number of solutions, we consider n minus r variables. What is n here? 3. Rank is 2. So choose any one variable as constant, any one. Let us say z is equal to t. You can take y equal to t or you can take x equal to t. If z equal to t, substitute in the second equation. From this, I can write it as 7y minus 8z equal to 0. But what is z? T. So substitute z equal to t here. I get y value as 8 by 7 into t. Right. So from the first equation, we can write this as x plus 3y minus 2z equal to 0. So substitute y and z here. I can get x value as minus 10 by 7 t. So as you go on changing the values of t, we get different solutions, infinite number of solutions. So the infinite number of solutions are given by minus 10 by 7 t, y equal to 8 by 7 t, z equal to t. Right? This is how we find the solution for the system of homogeneous equations. In this lecture, we have covered consistency for non-homogeneous system and consistency for system of homogeneous equations. Right? Next lecture, we will be seeing few more problems on homogeneous system of equations and the solution. Thank you.